Alright, for day 2, as a reminder, the region bounded by two curves is given by f of x minus g of x, and a and b are those places of intersection. This one actually says use a graphing calculator to sketch the region bounded by the curves. I'm just going to go ahead and do that for you. You could do this on your graphing calculator and see the same thing. What you would find is that you've got a line that will be like this. That's for the g of x. And your f of x will look something like this. And it says that we're only supposed to go to x equals 1. So here's 1. And then we're talking about this area between the curves right here. So we're going to find the integral, and we're going to do this in terms of x, so from 0 to 1. And it's the top function minus the bottom function, so there's my top function. X cubed minus 3x squared plus 3x minus would be your negative 2x dx. So what we really have is x cubed minus 3x squared plus 5x dx. So we have x to the fourth over 4 minus x cubed plus 5x to the second over 2 from 0 to 1. When I plug those answers in, I end up getting 1/4 minus 1 plus 5/2. Plug in 1 everywhere. And then minus 0, because when you plug in 0, you get 0. So you get a negative 3/4 plus 5/2. Negative 3/4 plus 5/2. Well, that would be 10/4. So we end up with the answer of 7/4 for solution. There's just 2 problems today, so this is the second problem. I'm going to try to get the region sketched. On this problem, we're talking about going from negative pi over 2 to pi over 6. So I'm not going to concern myself with any other part. I'm going to sketch the sine of x first. The sine of 0 is 0. The sine of negative pi over 2 is negative 1. And then the sine of pi over 6 would be 1/2. So we know that a curve function, or a sine function, is slightly curved. So it looks something along those lines. And then the cosine of 2x, we really would be looking at what is the cosine of 2 times negative pi over 2, which would be the cosine of negative pi. The cosine of negative pi would be negative 1 also. The cosine of 0, so the cosine of negative pi was negative 1, and the cosine of 0 is 1. And then the cosine of pi over 6 is 1/2. So this is going to come up like this and then come back down and intersect. So the region that we're going to be finding the area of is right here. So we're going to go ahead and write the integral. We're going to say we're going from negative pi over 2 to pi over 6. Top function is the cosine of 2x minus the bottom function sine x. And this is in terms of x, so it's a dx. I will solve this integral in the next video. Alright, when we solve this integral, some of you may need to make a u statement here and say u equals 2x. Now some of you will have gotten good at the integrals, and you know that if you integrate cosine 2x, you get sine of 2x but you have to make sure and put a 1/2 out front because the U statement creates, I should say the du creates a 2, and then you need to move that to the other side, which creates the 1/2. Minus then the integral of sine is negative cosine, but that would make this now be positive cosine x. Then what we're going to have to do is plug in our negative pi over 2 and our pi over 6. So I'll start by plugging in the pi over 6. So I've got 1/2 sine of pi over 6 here would be pi over 3 plus cosine of pi over 6 minus, plug in your negative pi over 2, 1/2 sine of negative pi plus, plug in your other part, so I have cosine of negative pi over 2. Then you just have to go through and think about each one of these. So this is 1/2. The sine of 60 degrees is square root of 3 over 2 plus the cosine here of 30 degrees is square root of 3 over 2 minus, we have 1/2, the sine of negative pi is 0, and then the cosine of negative pi over 2 is 0. So this ends up being 0. And so when you combine and you add those together, you end up getting 3 square root of 3 over 4. If you can't see that, you just have to make a common denominator right here. So you have square root of 3 over 4 plus, this will be 4 over 2 square root of 3. And there's your 3 square root of 3 over 4.